Now we will discuss the Brachistochrone problem. What is meant by Brachistochrone problem? The Brachistochrone problem is defined as the curve joining between 2 points not lie on the vertical line. Not lie on the vertical line such that the particle falling from rest under the influence of gravity from higher point to the lower point of minimum time. From higher point to lower point in a minimum time. What is the Brachistochrone problem? The Brachistochrone problem is the curve joining between 2 points which not lie on the vertical line such that the particle falling from rest under the influence of gravity from higher point to lower point in a minimum time. Now we shall solve the problem. First we shall state the problem, Brachistochrone problem. Example, a particle slides down a curve. A particle slides down a curve in a vertical plane under gravity. Find the curve such that it reaches to the lowest point in shortest time. In this we have to find out the curve along which the particle reaches to the lowest point in shortest time. Solution of this is let A and B be the 2 points. On the curve not lie on the vertical line. Let V equal to ds by dt be the speed of the particle, that is velocity, be the speed of the particle along a curve. then the time required to fall an arc length ds is given by dt equal to ds by v, that is dt equal to root of 1 plus y dash square divided by v into dx. Therefore, total time of descent from A to B is T from A to B, TAB equal to integration from A to B root of 1 plus y dash square divided by v into dx. As the particle falls, or since the particle falls freely under gravity, there is decrease in the potential energy. Therefore, potential energy goes on decreasing and at a distance x below the point A, it is given by V equal to minus mgx, and kinetic energy is T equal to 1 by 2 mv square. But by the principle of conservation, of energy, we have T plus E, T plus V equal to constant. We have T plus V equal to constant. Initially, at x equal to 0 and v equal to 0, initially at A we have x equal to 0 and v equal to 0, hence the constant is 0. Therefore 1 by 2 mv square equal to mgx, and from this we can calculate v equal to root of 2gx. Hence TAB equal to integration from x1 to x2 root of 1 plus y dash square divided by, we shall substitute the value of v here, root of 2gx dx. Thus TAB is minimum, that is time required is minimum. If integrand functional f equal to root of 1 plus y dash square divided by root of 2gx satisfy Euler-Lagrange equation. Dou f by dou y minus d by dx of dou f by dou y dash equal to 0. Now from this, if we differentiate f with respect to y, we will get dou f by dou y equal to 0. This implies that d by dx of dou f by dou y dash is equal to 0. But dou f by dou y dash, therefore d by dx of value of dou f by dou y dash is y dash divided by root of x into 1 plus y dash square equal to 0. If we integrate this, we get y dash equal to c into root of x into 1 plus y dash square. Now squaring this, we will get y dash square equal to c square into x into 1 plus y dash square. That is nothing but c square x plus c square x y dash square. Therefore y dash square minus c square x y dash square equal to c square x, and hence y dash square into 1 minus c square x equal to c square x. Hence y dash square equal to c square x divided by 1 minus c square x. Therefore y dash equal to c into root x divided by root of 1 minus c square x. This can be written as root x divided by root of 1 by c square minus x. If we put 1 by c square equal to some constant a, we will get y dash equal to root of x divided by root of a minus x. And therefore y dash is nothing but dy by dx. Therefore we will get dy by dx equal to root of x divided by root of a minus x. Integrating this, we will get y equal to integration of root of x divided by root of a minus x dx plus some constant of integration b. Here we shall put x equal to a sine square theta by 2. Therefore dx equal to 2a sine theta by 2 into cos theta by 2 d theta, and therefore y becomes a into integration of sine square theta by 2 d theta plus some constant of integration b, and that is nothing but y equal to a by 2 into theta minus sine theta plus b. If y equal to 0, theta equal to 0. This implies b equal to 0. And hence y equal to a by 2 into theta minus sin theta. And therefore x equal to b into 1 minus cos theta, and y equal to b into 1 minus b into theta minus sin theta. We will get this value for b equal to a by 2. And this x equal to b into 1 minus cos theta and y equal to b into theta minus sin theta, these are the equations of cycloid, and therefore this is a cycloid. This is a cycloid. Hence the curve is a cycloid. For which the time of descent is minimum. Thank you.